Hey guys, so in this video we're going to talk about factoring out a GCF. So factoring out a GCF is just going to be the opposite of distributing. Okay, so if we had something like, for example, 6 times 4x minus 3. In order to do that, we've learned that we would need to distribute that 6, and we would end up with 24x minus 18. Now, factoring is the process of going backwards from that. So as you can see in example 1, we start with 24x minus 18. Our goal is going to get back to this, the 6 times 4x minus 3. So how do we do that? First step is always going to be finding the GCF of all the terms. So in this case, 24 and 18 have a GCF of 6. So we're going to take that GCF and we're going to divide each term by it. Now, before we actually do the division and write out our answer, whatever we said that GCF was, whatever we divided by, that is going to go outside a set of parentheses. On the inside of the parentheses, we're actually going to do the division. So 24x divided by 6, that would be 24 divided by 6 is 4, and we leave the x alone. The negative in the middle can actually just come down in this case since we're dividing by a positive, and 18 divided by 6 is 3. So as you can see, we got back to 6 times 4x minus 3. Now for this first example, we knew the answer, but let's move on to one where we don't. So let's look at example 2. First things first, we need to find the GCF. So GCF of 8 and 12 is going to be 4. Now in this case, W shows up in both of those terms. If W shows up in both of the terms, then we need a W. And remember, we just take the lowest exponent that we see. So 2 and 6 are the exponents. So 2 is lower. The GCF is going to be 4W squared. So that is what we're going to divide each of the terms by. 4W squared. Now remember that 4W squared, that's just going to come outside of parentheses. On the inside, we go ahead and do the division. So for the first one, 8 divided by 4 is 2. W squared divided by W squared, that actually just cancels out, so we're just left with 2. For the second one, 12 divided by 4 is 3. W to the 6th divided by W squared, we just subtract the exponents, so we have 6 minus 2 is going to be W to the 4th. That whole thing is the factored version. So example 3. 3 terms, doesn't make any difference. We're still going to do it the same exact way, starting with finding that GCF. So what is the GCF in this case? We have to look at all 3 terms, so 60, 12, and 18. The GCF of those numbers is going to be 6. P does not show up in the last term, so we're not going to have P in our GCF. It's just going to be a GCF of 6. So we're going to take that and we're going to divide each of these by 6. So remember, that means the 6 is just going to come outside, big parentheses for our division. We do 60p squared divided by 6, so 60 divided by 6 is 10. P squared just comes down. Negative 12 divided by 6 would be negative 2. P just comes down. Negative 18 divided by 6 would be negative 3. And that would be our answer. Next up, example 4. So again, we need to start by finding the GCF. So GCF of 8, 12, and 44 would be 4. Then C does appear in all 3 of these, so we can also go ahead and put C there. That means we're going to divide each of these by 4C. So the 4C comes out front, big parentheses, and then we start the division. So 8 divided by 4 is 2. C to the 5th over C means we do 5 minus 1 is C to the 4th. Next, 12 divided by 4 is 3. C squared over C would be 2 minus 1 is 1. Last one, negative 44 divided by 4 is negative 11. And the C's actually just cancel out. So this is our answer. For example 5, again, always start with the GCF. So we have 3, 1, and 9. Well, out of those, the GCF would just be 1. Right? You don't have to write this one, but I'm going to go ahead and do it right now just to make sure everybody remembers it. Then if we look at the variables, x is the only variable that shows up in all 3. So since x is the only one that shows up in all 3, we're going to put x, and we take the lowest lowest exponent. So lowest exponent in this case is 2. So it's just going to be x squared. We don't have to write that 1 from this point on. If you want to, you can, but it is absolutely not required. And I'm just going to go ahead and divide them all by just x squared because the 1 won't actually matter. All right. X squared comes out front. Big parentheses. Then we start the division. So all the numbers are going to stay the exact same because we're just dividing by 1. Only thing that we're going to have to change is the variables. So 3 divided by 1 is 3. X cubed over x squared, 3 minus 2 is 1, so it's just x. For the second one, x squared over x squared, usually when we see that in division, we think it just gets crossed out. All right. Now, the reason that things normally get crossed out is the fact that it's just 1. So normally it doesn't matter, but we do need to signify that there was a 1 there. So if nothing else is left, we're just going to put plus 1 there. For the last one, 9x squared y divided by x squared. So in this case, we can think about the x squareds as just canceling out since there's stuff still left. And what's left is 9y. All right, example 6, negative 4x cubed plus 32x squared minus 20x. So start off with the GCF. So in this case, the GCF would be 4 and an x. However, there's something a little bit different about this one. This one actually starts with a negative. Now, anytime we're looking for a GCF and the first term is negative, we're going to want to factor out that negative. So we're going to make negative 4x our GCF, which means we're going to divide all of these by negative 4x. The negative 4x comes to the outside, big parentheses, and we start our division. So for the first one, negative 4 and negative 4 go away. X cubed over x will be x squared. For the second one, 32 divided by negative 4 is going to be negative 8, and x squared divided by x will just be x. Then negative 20 divided by negative 4 will be positive 5. X over x cancels out, so we don't have any x's left over. That would be our answer. All right, example 7. So for example 7, for this one, remember, we're looking for what's in common. So in this case, GCF is going to be 6x plus 5, because that's what's shared in both of them. All right, it's a bigger GCF than all of the other ones, but that's perfectly fine. We're still going to do the same thing. We're going to divide both by 6x plus 5. The 6x plus 5 is going to go to the outside, and then we put parentheses for when we divide. Now, luckily, 6x plus 5 and 6x plus 5 just cancel out. All that's left is x. Similarly, in the second one, 6x plus 5 cancels out again, and we're left with plus 9. This whole thing is our answer. All right, last two. For example 8 and 9, they're both going to be very similar. So for example 8, the GCF is going to be 5y minus 2. So that's what we're going to divide each of these by. 5y minus 2. Whatever we divide it by comes out. So 5y minus 2. Then we start division, so it cancels out. We're left with 6y for the first one. The second one, again, it cancels out. We're left with negative 5. All right, last one. The GCF is x minus 3 so we divide each of these by x minus 3. Now, when we divide each of these, whatever we're dividing by comes out. And then in both cases, again, parentheses just cancel out. And we're going to be left with 3x minus 2.